Okay, so like I said, we're gonna record the lectures. That's what this is doing. It's like meant for if you play video games or whatnot. I don't know if I should be recording this. The students here. It's got everybody's ID number. So anyway, switch it over to that. There's 6 people total in the course, so half of us are here today. Looks like there's one other. Oh wait, Ella is.
Ella doesn't? She's not in the course, but she said she may want to sit in. Is she already? Yeah.
Oh, she took it. Let me see who. Yeah, so Ella is not in it. So we're missing Justin from up here today, although I've never heard from him. Did you ever hear from him when you were trying to? Yeah. So he may not know that he's in a geography course because he's a geology geology graduate student. So he may drop it. Who knows? And then we just have Corey and Maggie on the coast. So it's a little bit lower enrollment than normal, but that's okay. This course is taught usually once a year. Dr. Reese says that he wants to switch back and forth between me teaching it and him teaching it, which I guess is okay with me. So I've only taught this course once before, which was not the last time it was taught, but the time before that. I think Chris Hare is the only one still here that remembers me teaching it. But I taught it when he entered his master's student. We do follow. I forgot to mention the book. We do follow the book pretty well. Although there's so few of you, did anybody, I don't know, did any of you all buy the book? Okay, all right. There's so few of you, I've got a book, so if you wanted to just share the book, you probably could. I could put it in the grad offices, whatnot. There's also an exercise manual that goes with it, but I just posted all that online. So if you go to like chapters 1 and 2, the exercise manual that goes with it are posted as a PDF. So it's like $15, but yeah, it's all posted up there on the internet. From the last time I taught the course, I just scanned them all in, and I didn't even remember I did that until this morning, and I was like looking through my old emails about the course, and I saw all the PDFs for each of the and I said, I forgot to tell the students to buy it, so I'll just put it up there. So, all right, so that's that. Course format. The syllabus that I made up is rather simple. I took a lot of the information from the time I taught the course last time. This is a pretty basic quantitative methods course. So it's not like it's not super advanced. We are teaching at the graduate level, and at other universities, I see this taught everywhere from. I see the courses taught using this book everywhere from the graduate level, like we're doing it, down to an undergraduate, usually a 300 level course. But you may have taken a course like this. In fact, that's one of the questions I wanted to ask. Who's taken a course like this at another university? Okay. So as an undergraduate, you took a course similar to this. What's that? Ours was a 247. Did you use the same book by any chance?
I don't know, but I haven't seen what the book is. I don't think we I took a 2 and a 300 level statistics.
Okay.
Like 5 years ago. No, we did a different one. Ours was quantitative analysis of statistical sciences or something.
Okay. Was it in a geography department? Okay. All right. Well, the last time I taught this course was similar backgrounds. People had some experience using statistics, and so what I can tell you is that for the first couple weeks, maybe it's a bit of a review, and the snow will make it short anyway, so at least for today. So we only have an hour today. We'll try to get through the lecture that I prepared, and pretty basic stuff that you may have even learned even if you didn't take a statistics course that we'll be talking about the first couple of days. Later in the course, what I plan to do is follow the book, but show some of the tools that I use when I use statistics in research. Sometimes that just means using Excel. Excel has a lot of statistical operations that you can do right in it. SPSS is another tool. Unfortunately, we don't have a global site license for SPSS, but we will install it on a couple of these computers. It's a statistical software package that performs a lot of the analysis. And once we start talking about some of the spatial analysis, SPSS doesn't do that right out of the box. One of the good things I think about this book is that it kind of breaks the problems down into pretty small problems and forces you to compute a lot of these spatial statistics, at least the beginning spatial statistics, by hand. So you really get to see what it is that they're doing, and it helps you understand it a little bit better. But I'll also show you how to do a lot of these analyses can be done right in ArcGIS, the spatial ones that we'll talk about later in the course. And then also, the other course I'm teaching this semester is Python, and it's programming. And although I don't expect you guys to learn how to program in this course, unless you're also in that course, I will also show some examples using Python, but they'll be kind of like recipes, like show the recipe, and Python's a free tool, and so if you ever did want to get into using Python for statistical analysis, you can kind of start off using those as recipes. So it's a good tool. Now there's a open source tool that lots of other researchers use. It's another programming language called R. I've kind of dabbled in R, but I don't know as well. But a lot of stuff we're doing can be done right in Python. So I'll show that as examples. Not today, because we don't have time, and I didn't prepare those yet. But as we move through the course. So the course is presented in lectures. We're going to talk. It's going to be kind of like a seminar. Hopefully we'll have input from the small class. It's not a lab course, but we're still going to have weekly assignments, and I'll show you the schedule here. Actually, I'll do that real quick. But first I'll talk about grading. Basically, we have 2 exams, and the assignments are all about equally weighted. Everybody should do pretty well on the assignments if you complete them. There's some math involved, but it's not anything that's harder than algebra level math. And then I'll show you some tools to assist you in that part of it. So this is the text. Like I said, we can all borrow my text, or you can purchase it. I have no idea how much it costs. How much does it cost? Yeah, it's not an extremely expensive book.
I got it on Amazon.
Yeah.
The library has a copy of this edition.
Yeah.
And I requested it before break, but now that it's a required text for the course, it's library use only.
Oh, okay.
You can't check it out.
Yeah. Yeah, it's not a super expensive book. My office hours, I'm going to be on campus most Tuesdays and Wednesdays. So those will be the best times, but I can set up a meeting anytime. All right. Just remember, you'll be getting emails based on your USM email account. That's that. So here's the course schedule. Like I said, we follow the topics of the book, but I'll try to throw in some more information as we go through each topic. So these are pretty much the topics as listed in the book. We're going to cover all the way through chapter 10 before the midterm, The midterm will be on March 8th. I will not be here that day, but we'll find some way to proctor the exam. And then we'll have spring break, and then we'll go through the rest of the chapter. So the book divides this up, but the first few weeks we're talking about background and just the kind of statistics that you think about when you hear the word statistics, which are really descriptive statistics. You know, your means, modes, standard deviation, and all that. We'll talk about a little bit about charts there, and then we get into the foundations for inferential statistics, which are probability theory, and then finally we begin to talk about inferential statistics before the midterm. And inferential statistics just means being able to make a judgment about a population without knowing every detail of the population, only knowing some of the information about the population. For example, this is, kind of geographic, just looking at election results or something like that. But you could also do a environmental example if you wanted to know what the content of a pollution content of a lake might be. You don't know what it is in the whole lake, but if you took some samples of the lake, what sort of statistics would you use to describe how much pollution was in the entire lake? That'd be an example of a population. We'll talk about some of these terms actually today, but we'll talk about them as we move through. And then after the break, we go in and we start to discuss different tests. And starting in April is when we really kind of hit the spatial part of this course. All right. And then we have a final exam. The final exam is okay. So originally this was a night class. So the final exam for a night class is supposed to be on the last day of class. So I kept it there when I changed the syllabus, but I guess if we got really late or something, we missed a lecture, we could move that to the proper exam time. But for right now, I'm just going to leave it like that because it fits well. Yeah, well, no problem. I appreciate it. Yeah. Reason why I'm teaching this class. All right, I was a statistics minor as an undergraduate, so I do enjoy doing this sort of thing. I do use it in my research, so it's a good tool to have. Let's talk a little bit about it. Statistical analysis. This is the first PowerPoint. There's a lot of text in this PowerPoint. I should have put some pictures in. I took one of the pictures from the book and put it in, but looks like the thing is still going. Okay. I guess it's this one. Oh, I'm gonna. So in the first chapter, we're going to talk about how statistics fits into geography. You know, geography is a pretty broad discipline. There's a few things that tie us together as geographers. I don't know each of your research interests. Maybe that would be a good question to ask. But Yeah, maybe we can do that real quick. What's your general? What do you think of when you think of yourself? You're all geography, right? Yeah. Okay, Mary. When you think describe yourself as a geographer, what type of geographer?
Human geography, particularly I like to look at the social as well as the environment stuff going on with it. And I'm focusing on education as being a key component of community development. But
Cool.
I've also taken a lot of sociology, kind of look at how race interacts with communities. And it's a big view of community development.
Okay. Thank you. All right.
That's pretty similar to Mary's, but
Okay.
it's international development, still community development, but it's more on like economic levels or sub-education. But still like global community development,
Okay.
developing countries.
All right. So far, a little bit more on the human side. Yeah. Go ahead.
So I do hazards, and my thesis topic is going to be looking at disaster resilience on the parolee population on the coast.
The parolee population.
Yeah, so from the statistics, I think I need, what I'm trying to do is compare the things that influence hazard vulnerability or resilience at the community level, and compare those to things that affect prisoner reentry, the individual level. So I need to learn how to do things like hotspot analysis.
Okay. Yeah, we can talk about that.
Yeah, and general, like, spatial statistics.
Okay. Cool. Yeah. So, your advisors, do you all have advisors yet? No. No. So 2 Millers and Dr. Cochran. All right. Sounds good. Yeah, because Cochran kind of got into hazards as well.
Yeah. Yeah, well, I guess he's the only person that's doing
Right,
hazards.
right.
Yeah.
All right. Well, I mean, I've done some stuff with hazards, but it's not really resilience. For spatial analysis. So I guess I should also say that I am a quantitative geographer. Basically, I like to do spatial analysis. I like to come up with ways to quantify the relationships that different entities have with each other by looking at how far apart they are, how they're related spatially, and I use all sorts of tools, but I mostly applied my work to conservation, which does have some human component, and I do a lot of remote sensing. So, anyway, statistics, I think, can play a role in all of the research interests that we talked about today. And I think from the beginning to the end, from everything that this course talks about, you should be able to apply and find a way to apply it to your area. I don't know that much about the first and third author, but the second author, who also wrote the workbook, he does. He's a human geographer that does a lot of work in like international, looking at quantitative methods for describing different interactions between people and the environment. So, all right. So we're going to discuss the steps and methodologies in performing research, kind of general stuff, and identify some key terms, like I mentioned before. What time is it? All right. We're already 3/5 of the way through the time that we have today. And I do have a meeting in between with the students. So, geography is a spatial science. I think that is one thing that ties us together as geographers. Is that, we're talking about space. We know what the word spatial means. It's how things how things interact, outer space, but how things interact on the surface of the Earth, and how human activity varies from place to place, and what are those relationships, the distributions of features, how they relate to each other. Humans have been doing geography for a really long time, even before they called it geography, really. Okay. I think you guys can read all this stuff, but I think here, this is an important point to remember. So geography continues to evolve in its current form. The problem-solving tool when people begin using it to predict future patterns. So, yeah, I skipped a little bit ahead, but all right. Today we're going to talk about what different things that statistics allows us to do. We can summarize the data. We can make simplified generalizations. These are pretty much the topics that we're going to cover today. This is more in the middle of the course. And then we're going to look at spatial patterns and spatial location later in the course. We're surrounded by statistics all the time. I grew up as a kid. I don't really follow baseball much anymore, but I grew up as a kid in St. Louis, and baseball was like pervasive at the time. This was the 80s. The Cardinals won a couple World Series back then, and so every day we were out pretending we were some St. Louis Cardinals baseball star. I can name them all, but I'm not going to. It was interesting that we boiled down all these people's lives into a bunch of statistics, and baseball particularly fits that method of analyzing things well, because a pitcher has how many times he can get somebody out, how many times you get on base, all these types of things. But all sports use them. But those are some examples. For people that aren't interested in sports, we've got weather, we've got advertising. They all use statistics. And it's important to be able to do statistics right, to be able to convey a proper story. So in order for statistics to be truly meaningful, it must be placed within the context of a quantifiable research process. We're going to define these two terms, qualitative and quantitative. You've probably heard them before. So qualitative is a description of an object or an entity based on its physical characteristics. I'm a little overweight, but I'm around 6 feet tall. Those are kind of qualitative. I guess 6 feet is almost quantitative, but it's not a precise qualitative. The quantitative means using a numerical measurement. Okay? Estimated 3,000 people waiting to buy tickets. All right. This is a key point here. I should have made it a little bit brighter. One of the things that happened in geography was that geography was fairly qualitative in its analysis. People would describe places. Sometimes we still refer to that as like regional geography. So geographers were mostly taking their articles consisted of describing places and the interactions that occurred there spatially, describing the flora, the fauna, the people, what people did, how they interacted with their environment in different places. And today we refer to that activity as regional geography. It's still a valid thing to do, but it's very qualitative in nature. And geography wasn't the only discipline. In the 50s, in fact, just before the 50s, economics really started focusing on quantitative methods. Describing how the stock market is affected by this. So that would be like micro, and macroeconomics would be like looking at gross domestic product and supply and demand and how it affected all that stuff. But geography really took a hold of this as well. We weren't the only discipline to do that. What we refer to this time period where geography was really infused with quantitative methods, statistical methods, as the quantitative revolution. This occurred in the 50s and the 60s, and changed geography so that the people started doing, that's when the term spatial analysis even got coined. GIS as a tool was invented, or maybe it wasn't called GIS, but it started to be used as a tool starting in the late 60s, early 70s. It was a result of this process. Geography spun off other disciplines like landscape ecology during this time period, and it continues to kind of dominate geographic analysis, quantitative methods. So it was seeking to make, well, maybe not, because it just happened, but some people that focused on quantitative methods were trying to infuse geography with science, basically, the scientific method here. This research methodology follows, or is similar to the scientific method, where we identify a problem and then develop questions, collect and prepare data, and then process descriptive data. As geographers, sometimes when we're processing descriptive data, we can create maps. So we don't often think of maps as descriptive analysis, but this is actually so much more true nowadays when we can bring up a GIS, a data in GIS, and kind of look at different maps of the same data. You can create a dot density map and a choropleth map, and we can take the choropleth map and look at an equal interval classification scheme and a natural breaks classification scheme. We'll talk about that just in case you don't know what I'm talking about, but that's really visualization of descriptive statistics is what that is. So that's very similar to another discipline when you might just create a graph, a scatter plot, or bar chart. We'll talk about those things. That includes maps. So you reach conclusions by looking at the maps, and then you can formulate a hypothesis. Like you could say, okay, well, it looks like a certain income level or racial group or educational attainment level, they respond to, this disaster this way. You have to come up with a quantitative way to describe it. And then you can test your hypothesis. After you collect data, you can test your hypothesis. And this hypothesis testing is one of the things that we'll discuss in this course. And you can use that to either say, yeah, it looks like that hypothesis is true, or it's not, and I have to change a few things. One of the things about this diagram is that it's meant to be thought of as a series of fluid steps, where any step can be revisited as needed. In the interest of time, I basically went over all this information, but this is an example using Census Bureau data. Have you all used Census Bureau data in your research? Probably, yeah. Okay. So this is stepping through this, what I just stepped through on the diagram. Okay. All right, here's a few things. All right, I don't know why we keep insisting on this, right? So I remember the first time I got shot down because I didn't use the word data as a plural. So remember, the data is plural. back when I was a senior in college or something. No, data is plural. But it's the plural form. Everybody here probably already knew that. Meaning a group of the most basic element in statistics or numerical analysis. So the singular is actually data. And so I've always had the question, like, well, if data is already plural, then why do we use the term data set? Right? Because data set, that's like to singularize the plural. So data set can be singular. So you can say, this data set said this, whereas you have to say, these data indicate this. You can say, this data set indicates this. All right. So anyway, just to make sure everybody knows that, data set is a collection of several data. I guess the key here is that a data set is usually organized into rows and columns, but so is data really. And it's got a thematic element attached to it. Okay? The data set, rows and columns. There's all sorts of words that we attach to the rows and the columns, but lots of times in statistics we refer to what we call an individual or a case or an observation as a row in the data set. Okay? So if we were all in the data set, all four of us, we would each be an observation. Okay? And a variable is a characteristic of that observation, which can be counted or measured. So that's a column. Our ages, our incomes, our educational attainment, we could all store those as numbers. Like the last grade we went to, we could store that. We could also have variables. I'll talk about this in a second. It's even in this class where we're talking about quantitative analysis, it's often helpful to have data variables that divide a set of observations up into categories so that we can test. We can say, okay, are the males in this group different than the females in this group, or the different races, are they different? Are the people that are earning a lot of money? Is there some other category? So variables can be qualitative or just a label, and they can be quantitative. So counted or measured doesn't necessarily preclude qualitative information. In fact, we'll use plenty of qualitative information in this course, but we're analyzing it using quantitative methods. We're going to use numbers. Okay, so a data value is an individual measure or count for each observation within the data set, basically the intersection of a row and column. So the data value, the age for me, for at least the next few months, is 42, and that would be an example of a data value. Descriptive statistics, that's one of the things that we'll talk about today, but those are things like calculating the mean, the mode, the standard deviation. Hopefully you've done that sort of thing before, but we will briefly talk about that. Okay. So inferential statistics, I've used that word already, but inferential statistics allow us to generalize the statistical population, which is based on the sample population. And typically, we use the same things. So simply put, okay, we'll get a little bit more into everything, but simply put, if we have a good sample of a population, and we take the mean of the population, we should expect the mean of the sample, we should expect the mean of the population to be similar. But how similar? That's what inferential statistics does. It allows us to make a judgment and say, okay, well, most of the time we take a sample of this size, 4, and 4 of us. We can make a judgment about the population. Maybe the population is all the people on campus. We make a good judgment about the population that it has the same mean within a certain range. Of course, four would not be a very good sample size, but so we have a large level of error associated with our measurement, but we can quantify that. All right. So statistical population is the total set of information under investigation in the study. Sometimes this is actually a issue with geographic data, and we'll talk about tackling some of these issues later. But for example, if you use census data, we already have a population. We already have everything. So what does inferential statistics really mean when we're dealing with the population using, for example, if we want to find out if men make less than women, that's just something I came up with off the top of my head. In the United States, well, since income level, income is a census variable, I'm pretty sure, maybe I'm wrong, but it's at least on the longer form. We could look at that, and we could come up with the average amount of money men make and the average amount of money the women make. Do we have the answer for the population already, or do we need to make an inference and see if that's really going to be an issue? Well, that's the kind of things that we'll talk about later when we get into inferential statistics. All right. A sample is a subset of observations based on a statistical population. All right. So that's that one. We got 6 minutes. Might not get all the way through it. That's just fine because I want to do a few examples next week. Files. Let's just bring this up real quick. I've already got actually all the chapters up there, although I only have 3. Just so you know, all the exercises. Although I only have 3 of them posted on their website. Okay, so this is chapter 2. Nope, that's not going to work. I got to download it. There we go, download. Okay. Yeah, so you want to get it. You probably want to get a lunch for sure. All right. Yeah. All right. Because you got to eat it. All right. So we'll talk about a few more definitions here real quick. This is chapter 2. So in chapter 2, it talks about data sets, and data sets can be in different levels. Okay? We can get a data set that has individual level data, like the census is a good example of that, or at least an individual. Not necessarily. Individual doesn't necessarily mean like one person. So with census, it's usually talking about a household. But they're still individual households, not aggregated. However, they do have census data that is aggregated. You can get it by block group, and it contains aggregated information at the block group to track. In fact, for the census, you can't get individual household data until certain time periods pass, right? I don't know what that is, but I do know that's the case. So you can't figure out for this particular household what their income was. You can only get information. I think the smallest one is block. You can get block information that's aggregated. And so a lot of spatial data sets will be aggregated. And one of the kind of issues with aggregation is that it brings into this. This is a common topic in geography. It's referred to as ecological fallacy. It's the invalid transfer of conclusions from spatially aggregated analysis to smaller areas or to the individual. In other words, not everybody that lives in an area where the average income is $30,000 makes $30,000. So You can't. That's a simple example, but there are more complex examples, and it gets a little further convoluted when the aggregations are completely arbitrary, like census blocks are. Okay, who creates census blocks? The government, right? Yeah, and zip codes and everything that the government creates. In fact, even states and counties are arbitrary units, right? So, anytime that these units have been created arbitrarily, they can sometimes lead to a conclusion that is only applicable at the aggregation level that the analysis was run. So like if we find a pattern in our data, it's not necessarily the same pattern. So I gave an example of a specific variable, but like let's say that we find that, well, this is still simple, but now it's a pattern. Let's say we find that really, well, from your example, parolees aren't really prepared at the county level. There's a really strong relationship between people being a parolee and being not prepared for disaster versus at the state level or even at the block group level, we may not see the same strength of that relationship, the relationship strength, which we haven't even talked about how to quantify yet, but it may be totally different at a different level analysis, even for the same area. So like looking at, and trying to figure out what that always means is another thing to wrestle with. So it's best to always, when we use spatially aggregated data sets, to always limit our conclusions to the spatial aggregations that they represent, rather than trying to project them onto individual data or even higher levels of aggregation. Okay, so like a census data, you know, like a block group is, and a block and a tract. Okay, so the income level for that tract is an aggregation, whether it's the sum or whether or not it's the mean. It's still an aggregation. It's not the household income for any individual. It's an aggregation.
Like summary?
Yeah, it's a summary or spatial aggregation of individual units.
Okay.
So yeah, and I know most of you all are human geographers, so you understand the census example just fine. But even if I let's say I got satellite data of the United States, and I got like 1 kilometer satellite data, and I found out that rainfall and the brightness of the vegetation was related really well at 1 kilometer. I might not find the same pattern at if I got 30-meter data, even of the same area. It might not have as strong of a relationship, or usually, this is usually the case. Usually, as you spatially aggregate, you'll actually get stronger relationships. It's not always the case, but you'll be able to see patterns stronger than at a higher degree of spatial aggregation than you will at a fine level of detail. And like for me, like remote sensing, you can understand this because at a very fine level of detail, you start getting more and more noise. Like you get shadows and different pixels that don't look quite right, and so your relationships can get all messed up. But if you kind of look at the whole United States as a big picture with big 1 kilometer pixels, a lot of that stuff goes away, and you get a much stronger relationship between your variables. So, but when you do so, so looking at the whole United States, it would be very valid to try to use remote sensing data to come up with the crop yield that's going to happen for the central United States to predict what it's going to be based on rainfall using remote sensing data. It'd be valid, but it wouldn't be valid. Maybe it would, but maybe it wouldn't. So who knows? But you shouldn't then look at a county, even a large county in Texas that might have, thousands of pixels, 1 kilometer pixels in it still, but that same relationship might not apply over that smaller, spatially aggregated area. Okay. We did talk about this difference between a discrete variable and a continuous variable. A discrete variable is a variable that has some restrictions placed on the values. Oftentimes, a discrete variable is a qualitative value, like a label. A continuous variable is a variable that has an infinite number of possibilities. So sometimes they're related, but not necessarily the same thing. Qualitative and quantitative values. Okay, let's just finish let's talk about the 4 levels of measurement, and then we'll be done. All right, so I know I talked about this even in my GIS class, so you may have had this information before, but actually let's talk about this next time. And I'm going to go over the assignment, because you can go through that pretty well, and it's 2018 already. You can go through that pretty well. So here's the chapter assignments. You can feel free to complete these any way you want. If you want to print them out, you can do that. If you want to just answer the questions, just say 1 and answer the question, and 2 answer the question, and upload that. That's fine with me. Everybody has access to the copy machine upstairs? Okay. So if you do print it out and write everything, what would be best is if you go to the copy machine and just hit email, and it'll create a file, and then you can send that file to me or upload it to Canvas. That'd be great. All right. So what you do is answer the questions here, and we talked about chapter 1. Chapter 1 basically has you go through and kind of think about that process that we talked about today. That's similar to the scientific method. And then it has you do a little exercise on mapping. And then chapter 2 is similar.
So are these 2 before each test each week?
Okay, so that's a good question. Sorry, that's one of the things I was going to talk about. So I made them do, where did I put the due date? Due date, January 26th. So each of them will be due on the Friday. So basically you have 8 days. So I have them all posted. You can do them all right now if you wanted to. But they'll be due 8 days from when they're posted, and that'll keep us going on track. I know in my GIS classes I usually say 2 weeks, but these aren't super difficult. Feel free to work. There's only 3 of you. Feel free to work together, ask questions of each other, come in and ask me questions, and then I think 8 days should be enough time.
The 2 weeks.
Right. Okay.
Rather have it fresh. But we go by the due date when you show on the January 6th. It's always going to be the due date show.
Right. It's going to be the due date show, but for the modules I've already created, it's it's always 8 days from that class period. So they're due on the Friday. So we have class on Thursdays. They're due the next Friday. And but they're not due till midnight, like 11:59. That's the default. So you have a full 8 days. I mean, pretty much. All right. So I'm going to also post this this lecture up there.